All right, we're back. This is Notes 3 of Calc AB. We're on page 5. We're on part D. We already found some position functions from some velocity functions. We talked about how we can reverse the power rule, which is a big deal. You need to be able to do that. Obviously, there's going to be tons of practice on that later. This is just like an introduction of the concept. We also ran into some special functions that we know the derivatives of. And if we didn't know the derivatives, we would not be able to work backwards. So for example, we ran into 1 over t and we thought to ourselves, well, 1 over t feels like the derivative of natural log of t. And it is the derivative of natural log of t. So we went backwards. We had to throw in some absolute values for kind of like complicated reasons that we didn't talk about too in depth. But if you don't know the derivatives you're supposed to know, this process is almost impossible. So you've got to know them. So I knew that the derivative of cosine is negative sine. That helped me go from a negative sign back to cosine. So let's see what we can do here. So this feels like, to me, this feels like some natural log stuff here, right? They're both basically just 1 over t with like, a shift left or right. Why would that change the function that you get? It wouldn't. So let's see. So I'm going to say s of t is going to be, all right, so what do I take the derivative of to get 1 over t plus 1? I think that it's the natural log. I'm going to throw in the absolute value for domain reasons, but if you don't like that, it's okay for now to not worry about that. If I took the derivative of natural log of t plus 1, it'd be 1 over t plus 1 times 1. I think we're good. And then here, I think I'm actually just going to get t plus 3. And if I took the derivative of natural log of t plus 3, I'd get 1 over t plus 3 times the derivative of t plus 3, which is 1. So I think that's right. And then we have to put in a plus c. So where did each of these things come from? This comes from this one, gives me this. And then the next one, this comes from this. So now, strictly speaking, because I can't avoid telling you, strictly speaking later on, oh no, I missed like a little spot. That's going to drive me, God, I don't know which is worse. I'm just going to miss the spot. You can drop the absolute values here for domain reasons, but let's not worry about the domain too much on these. It's not really the point. The point at this juncture is to find C. So let's see if we can do that. So I know that if 4 is going to be the natural log of 1 plus 1 is 2, plus the natural log of 1 plus 3 is 4, and then plus C. So this is going to be a kind of gross C value. I'm going to say 4 equals natural log of 2 plus the natural log of 4 is actually the natural log of 4 times 2 of 8. Never miss an opportunity to use those properties. If you can use them and think about them, you should do that. So I'm going to say C is 4 minus the natural log of 8, which is, that's a weird C value, but it is, I believe, the correct C value. So we're actually going to find out in a second when we get to the calculator part. So I think S of t, I say a second, that's like a serious underestimate. So I'm going to drop the absolute values because you'll learn later that you can on this particular problem. And they're kind of annoying to write. So I think I'm going to go with this. Calculator might say that the natural log of 8 is 3 times the natural log of 2 because 8 is 2 cubed and then exponents become coefficients. Could happen. We'll see. All right. What do we got here? Okay. So now we've got an acceleration, which is just 6. Then we have a velocity at 0 is 4 and position at 0 is 5. So this is actually some extra steps here. I can go from acceleration to velocity in the same way that I've been going from velocity to position. What do I take the derivative of to get 6? It's just 6t, but there's a c. So far, this is going to take a lot of highlighting. I don't know if I have enough highlighters for this. I mean, I have an infinite number, but I don't have an infinite number of colors that I like to use, and that's an issue. We got this. I'm going to use this information to solve for c. And you can actually just see right away that that's the case. So v of t is 6t plus 4. Okay, so where did this 4 come from? So c is equal to 4. Okay, so now I want to go from velocity to position. So s of t should be, what am I going to take the derivative of to get 6t? So you have two choices. Well, you don't really have two choices. There are choices of how much simplifying you do. Think of 6 as a constant multiple. T is the derivative of what? So kind of t squared, but really 1/2 t squared. So I added 1 to the exponent and multiplied by the reciprocal of what I got, right? So t to the first became t to the second, but times 1/2 t squared. And then 4t, because you take the derivative of 4t, you get 4, and then a new c value shows up. So what am I gonna highlight here? I'm gonna highlight, what colors here? So I'm gonna say that this gave me this, and then, I don't know, this gave me this, and then I need to solve for this new c, which I guess I'm going to use this really sad gray color. This and this will allow me to solve for that c. All right, let's do it. So 5 equals, 6 and 1/2 is 3, and then I'm plugging in 0 anyway. 4 times 0 plus c. So c is equal to 5. Okay, so this, and am I highlighting this C? I don't know. I'm gonna highlight it. I don't remember if that's like, does that fit the highlighting scheme? Hard to say. All right, so S of t is 6 and 1/2 is 3t squared plus 4t plus 5. So to see if this worked, what we would do is start taking derivatives, right? The first derivative is going to be 6t plus 4, which makes sense. When you plug in 0 to that, you get 4. For the position function, I mean, definitely, if you plug in 0, you get 5, but that, makes most sense. 6t plus 4, the derivative is 6, which works. So it meets all the criteria. So that's our answer. That's our position given all that information. All right, let's see if we can do this one. So, a of t. So I'm going to go backwards from a of t to v of t. What do I take the derivative of to get cosine? So the derivative of sine is cosine. So if I have cosine to go backwards, I'll get just sine. Sine of t. But there could be a c, right? So far we had this, which gave us this, and then we get a c. Now, how do we solve for c? We're going to use the fact that v of 0 is 4. So what's nice about that is that the sine of 0 is 0. So 4 is the sine of 0 plus c. So we just know that c is 4. In this case, that's our first c. All right, so now we're thinking our velocity function is actually sine of t plus 4. Okay, we can go from velocity to position. So now, what do I know that has a derivative of sine? Well, I don't actually know a function whose derivative is sine offhand, but I know the derivative of cosine is negative sine. So the derivative of negative cosine should give me positive sine. You can check that in your head, and it definitely works. So that, we went from here to here. What do I take the derivative of to get 4? Well, it's just 4t. That's sort of unexciting, but we do get a new c, and that's kind of exciting. I don't know what colors I'm using anymore. Here to here, and then I think I use this sad gray color. That's our c value. We can solve for c using this information. So if I combine, what do I do? This with this, I get that -2 is the negative cosine of 0 plus 4 times 0. 0 is a really common initial condition. See, because like if it's time, like obviously, or not obviously, but you should know what's happening at t equals 0. Like that feels like the most natural. -2, cosine of 0 is 1, so -1 plus c. So I think c is -1 here. Okay, so let me highlight that. This c is -1. So our position function, s of t, is going to be negative cosine of t plus 4t minus 1. I believe that that is our position function. Okay, so I think these are all of our answers. Now the question is, can the calculator help us with this? And the answer is definitely. And so I'm going to switch over to the calculator. Sometimes this doesn't work. It's very, very depressing when it doesn't work. So let's see if it does. Hopefully you're seeing the calculator right now. So what I'm going to do, press menu, option 4 for calculus, then up to D. So press up like 3 times. Differential equation solver. Okay, so because I have a CX2, it has like a wizard that tells you how to do it. So what it's telling you is you have to put in your differential equation. So for example, I'm going to say S prime is equal to, I'm going to do I'm going to do D, part D, 1 over the quantity T plus 1 over the quantity T plus 3. Okay, so that's my differential equation that I'm solving here. These are called differential equations, by the way. This is, it's just an equation that has a derivative in it. That's a differential equation. So the derivative in this case being velocity, which I'm calling S prime because it's the derivative of position. Okay, I also know that T is the independent variable, S is the dependent variable. Conditions, S of 1 is equal to 4. The second condition is optional, so I'm not going to do it. I'm just going to press OK. Okay, so it sets this up. If you have a CX1 that doesn't have a wizard, type in this. You literally have to type A, N, D, and the space key is down here by Z. Very annoying. Press Enter. All right, what happened here? So the calculator, what has the calculator even done? Let me try to expand this. Okay, so is this the answer that we got? Maybe. We got the natural log of the absolute value of T plus 1 plus the absolute value of natural log of the absolute value of T plus 3. So far, so good. Then we got plus 4, which is good. And we got minus natural log of 8. But 8 is 2 cubed, so that could be minus 3 natural log of 2. We got that answer. All right. I'll try one more just to show you. So menu 4. Then I press up a couple times. I think that's the fastest way. I'm gonna do E. Okay, so what am I gonna do here? I'm gonna say S double prime because I know the acceleration is 6. That's it. And then I know the independent variable is time for T, and the dependent is S. I have 2 conditions. I know that S prime, or V of 0, is equal to 4. And I also know that S double prime, I know that S, of 0 is equal to 5. So let's see. I'm gonna press enter and see what happens. I don't know if the conditions need to go like position, then we'll see. Okay, so I got 3t squared plus 4t plus 5. It worked. Nice. Let's just do the next one because we're here. So menu 4, option D, S double prime is equal to cosine of t. And then independent is t, dependent is S. S prime of 0 should be 4, and S of 0 should be -2. I don't even remember using that. Okay, I guess I did. Press enter. I get negative cosine of t plus 4t minus 1, which is exactly what we got. So it worked. And your calculator is amazing at checking these things for you. So I'm going to try to go back to the notes so you can take a look. If it doesn't work, I don't know, rewind the video and take a look. So in the notes, it briefly tells you how to use the calculator to do this. So, and then it shows you exactly what to type in if you have a CX1. CX2 has this wizard that pops up and like walks you through it, which is kind of ideal. But anyway, I'm going to end this here, come back in the next video, and I think maybe finish up these notes. So hope to see you there.